Right. Okay, can you see my screen? You see my browser?
Yes.
Okay, perfect. All right, so let's get started. So uh, first of all, any questions from the material before the main discussion for this week? As usual, you can at any time you can stop me and ask me questions. Okay. Um, so there are quite a bit um, of material covered this week, and that is pretty advanced. So I'm not going to talk too much stuff out of the scope of this week because it's quite advanced, and I want to make sure all the students here have a clear understanding, especially around the scope. Scope is very, very
Mm.
important in all programming languages, and in JavaScript is no exception. Right? So in Udemy, it talks about a few scopes, like function scope, uh, block scope, and lexical, right? I think those are the
Yeah.
three that was covered. Yeah. Actually, there's one more. There's one more called the global scope. There may be a couple more, but it's important to also understand the global scope. So I would like to first start with the global scope, and then I will also cover the function scope, block scope, and lexical scope. And by the end of this session, I would talk about something called closure, which is very important. For some reason, it was not covered in Udemy, but I think it is very, very important. It's a bit difficult to understand, but it's an important concept. So let's get into it. So global scope. So global scope is basically any uh, variable or functions that is not inside a block or a function. It's just lying kind of like outside. And those uh, variables or functions are accessible, available everywhere in your code. So to give you an example, if I have a global var here, oh, it's a typo. That's why it's not doing the highlight. Okay. So let's say I define a global var, uh, global, right? So this is global scope because I'm just defining that at the root of the code here. So if I now have a function, for example, or before that, maybe if I just as a very trivial example, if I just console log in here, uh, it will work global, right? Because this is a global variable and I'm trying to access this global variable in here. It's okay, it works because it's global, it's accessible everywhere. So now if I do a function, uh, if I make a function here and then I do console log, it will also work if I call the function. Do you notice the problem here? If I run it, nothing happens, right? Because I haven't called the function, right? So let me call the function. It works, right? Global. So the global variable can be accessed from outside, from inside a function. If I now have a block inside a function, like a if block, for example, right? It's it's a dummy if because it's if true, but just to demonstrate the idea of a block scope inside a function scope, trying to access a global variable, right? And it works. It still prints global, right? So this is inside a block inside a function trying to access a global variable So this is called a global scope. Can anyone tell me if you think, what do you think about global scope? Is it a good thing or a bad thing? Should we avoid it or should we use them a lot? Any idea? Don't be shy. Just I like opinion, right? And then we can talk about it. Do you think global variables are good or bad? Would you, if you are to write actual code in real life, would you use a lot of global variable like this, or would you rather use global for other?
I think we should not use global variable because when it comes to real production, like other developers might accidentally use that variable as well. Yes. So it will
Excellent.
be
Yeah, yeah, excellent. That's exactly the reason, right? So when in real life, when you implement actual software in the real world, it's usually complex. Um, so many lines of code, right? And then if you happen to have global variable, which you will, right? There are some global variable that you cannot avoid, and some of them are intentional, but we can talk about that next time. But in general, as far as possible, avoid global variable because it's not a good practice. It can be accessed anywhere. If this is a let, that means you can change it anywhere. So it can become very messy easily, right? Um, so try avoiding global variable if possible. As a good practice, that will make your code more reliable and less error prone. So that's the first thing, global scope, easy, right? Um, okay, so next, let's talk about function scope. So so there is another name for function scope. Function scope can also be called local scope. So a variable that is defined inside a function has a function scope, and we often refer to those kind of variables as local variables because it's local to the function, right? So as an example, if I have a function, uh, if I make a function here, and then I do a local var, local, right? And I console log the local var. And of course, I have to execute the function, right? So do you think it will work? If you think it will work, you can click the raise hand icon. So no one? You can click the raise hand icon like the one that I just clicked. If you think it will work. No? Okay, so okay, I see one. Okay, so if you think it will not work, can you raise your hand? I want to make sure you know what I'm talking about. So you're not sure? Okay. Um, okay, so here we have a function, right? We have a function here. And inside the function, we define one variable named var. And we try to access this variable inside the function itself. So first of all, this is a function scoped variable or local variable, right? It's a variable local to the function func in here. If we try to access the variable inside the function itself, it will work. Let's first prove this is true. Okay, so it works, right? Local. However, if we try to access that outside the function, it will not work. It won't work. It's not defined. Even if I place that after the invocation of the function, it doesn't work, right? It just cannot reference It has no access because the local var is a local variable scoped inside this function. So it's accessible only inside the function, right? So that is called a local or a function scoped variable. So do you think it is a good thing or bad thing to use function or local scoped variable? Is it good or bad? And why?
It's good
Anyone? It's good. It's good. Why do you think it is good?
because some variable we use only in local, and we need only in local, and we don't need on in global. Yeah, we might be confused if we use it in global.
Right, right, exactly right. Yeah. So some yeah, usually a variable is intended to be used somewhere, right? So if we declare that inside a function, it can be accessed only within the function itself. So it is scoped locally to the function. So that means it will not leak outside of the function. It makes your code more reliable, predictable, less error prone, more easy to understand also, right? Because the variable, you don't need to worry about that. You know that this variable will not be appearing anywhere else in the code. Or even if you have another function somewhere in the code, if you have another function, right? Function two that has the same a variable of the same name, it doesn't matter because this is allowed and they will not interfere with each other. They will not interfere. So this is a very important feature because when you have a very complex piece of code, very often you may have name collision, right? And you want to make sure they do not interfere. Otherwise, it would be quite messy, right? So function scope is good. Try using local variable as far as possible. It will make your code more predictable, reliable, less error prone, more reusable, and so on, right? So function scope is good. Okay, so next one, we have block scope. And we kind of talked about that before, but let's, for completeness, if I have a if block here, and then I define a variable. Oh, var is a reserved word, so I cannot use it. So v, and then I console log v, right? So obviously it will work, right? It prints v because this is a block scoped variable, and I'm trying to access that inside the block itself, so it has access to it. And similarly, similar to the function scope discussion, if I now try to reference that outside of the block, it won't allow, right? Because it doesn't have access to it, right? So ungot reference error, v is not defined because I cannot access v outside of the scope of this block where it is defined. So this is block scope, very similar to the function scope. And therefore, very similarly, it is a good thing to use block scope variable, right? So if you have a function and somewhere in your function you have a if condition, if you have some logic here that requires some variable, and that is needed only within the block, it is better to define that inside the block, right? So what I'm trying to say is that if you have a function, and then inside the function you have some if block or some block, some loop or whatever, right? Like a block scope thing. Do it so, and then in here, if I need to access the variable, so here, just as a very simple example, I'm just printing that out. But in real life, you will use this variable to do something. It is better to define this variable here within the block scope, closest to where you need it, as opposed to defining that outside. This will also work, right? You can also place that inside a function, and it will still work. Let me verify that. Oh, I have to call the function. This is the part I keep forgetting. Yeah, so if I call the function, it execute the function, it declare this variable, and then inside the block, it has access to the function scope variable. But so this will work. But if possible, try moving that inside the block. It would be better. Of course, sometimes you cannot, right? Because you may need this variable somewhere else outside of this block. So in that case, you have to define that outside. But if possible, if this is only used within the block itself, define that inside it. So try to define that closest to where you need it, to limit the scope, basically, to limit that to the smallest one, closest to where you need it. That would be a good practice. So this is the kind of thing that, I mean, if you define that outside and you use that only inside block, nothing wrong. It compiles, it runs, it works as expected. But this is just not the best way to write the code. So this is something I would like you to keep in mind. And this is block scope. So far so good. Any question, any concern, anything you want me to clarify before we move on? Okay. If not, let's move on to a slightly more complicated but interesting thing called the lexical scope. So lexical scope is basically about nested functions, right? So let's say you have a function called outer function. It's the outer function. And then I have an inner function nested inside the outer function. So if I define a variable outer inside the outer function, so this is a local scoped variable for the outer function, right? Local to the outer function. Inside the inner function, I define another variable named inner, right? So in here, in this line, do you think I can access inner? So if you think this line will work, will print inner, raise your hand. If you think it will print inner, if you think this line can access this inner function, this inner variable, click the raise hand button. I want to see what you think. Okay, I see Sherry. Anyone else? So, okay. How about Hannah? What do you think? Do you think it will work, or it will throw an error, or it will just print nothing? Hannah?
Yes.
Yeah, what do you think?
I don't think it's work here.
You don't think it will work, right? Can you
Yes.
explain?
Actually, as I remember what I watched from the video, it should be console outside of the function inner. Yeah.
You don't think it will work because, so first of all, what kind of scope is inner? Is it a global? Is it a function scope? Is it a block scope? If I just look at this variable, yeah, it may be a bit difficult, right? So let me slow down a little
It's
bit. Right?
local.
Sorry, can you say that again?
I think it's local scope.
Yes, that's local scope because it's defined inside the inner function, right? So this is a local scoped variable, local to inner func. And since I'm trying to access that inside the same function itself, so at this from the with respect to this line, the inner is local, right? It's local to the same function, so it should be able to resolve it. But of course, I'm missing a few things here. Can someone tell me what I'm missing? If I run this code, I can guarantee you the thing will print. Do you know why?
Because you haven't called the function.
Yes, thank you. So I have to call, so in here, right? So this is inside the outer func. So in the outer func, I define an outer variable, I define an inner function, and I also call the inner function. So it will work, right? But on the global level, I also need to make sure I remember to call outer func, right? So from line 1 to line 9, nothing will happen. It will just register two functions. And then on line 11 here, I call outer func. It will execute the outer func, which will go here, define this variable, define this function, and call the inner func, which will in turn define the inner func, the inner variable, and print that out. So this is how it will work. So the expected output would be inner. And let's verify it. So it does print inner, right? So, and this is for inner. So if in here, if I print outer instead, what do you think? Do you think it will work or it will not work? Anyone?
I think it's work.
You think it will work, right?
Yes.
Yeah. So what kind of scope is it?
It for inner function, author function is global for inner function.
Mhm. So relative to this function, this inner function here, the outer is something we define outside of this function, but inside the function, the parent function. It's confusing, right? So we have the outer, you have the inner. So if we define a variable in here and we try to reference that from within an inner function, this is called the lexical scope. So this is when inner function try to use variable from the outer function that they are inside of, right? So I try to reference the outer, which is a variable inside the parent function. So when I try to reference outer from within an inner function, it is lexical scope. This is the one that is most difficult to understand. Don't worry too much if you are not 100% clear. So this is more of an academic discussion here. In reality, right, in real life, when you do coding, as you do more and more coding, it will become very natural to you that when you define a variable here, you define an inner function, right? And inside the inner function, you want to try referencing that variable outside. If you write more, as you write more code, you will know that it works. You do not necessarily need to remember. This is called lexical scoping, right? This is more like a theoretical academic kind of discussion, but it's good to know that, right? If you can understand that, it would be great. If you do not fully understand or fully understand how to distinguish between like global, local function scope versus lexical or block scope, it's okay. The most important thing is you know when you can use variable from where, right? So yeah, so to recap, right? So far we talked about global scope, which is something you define outside that is accessible anywhere. It's a bad practice because it can be messy. And then we have two very similar scoping, one called local or function scope, and the other one is called block scope. Those are variables or functions defined inside a function or a block. So you can access that only from within the function itself. So if I do not look at this function here, if I just look at this outer, right? So pretend that you don't see this function here. Then this is just a function scope or local scope variable. And it is accessible from within this outer func itself. This is called function scoping, right? So, and then, however, you can define nested function within function. And you can reference any variable that is defined in this kind of nested structure, right? You define it here in the outer func, and then you define an inner function. You try to reference that, it works. So relative to this inner func, this outer variable is a lexical scoped variable. So this is called the lexical scoping. So global, function, block scope, and lexical, 4 types. Try to keep that in mind. Try to understand that. If you do not fully understand, it's okay. It's quite complicated. But the most important thing is as you write more code, you will learn from experience and try to, from time to time, ask yourself what kind of scoping is this legal, is this working, and try to relate that to the 4 categories that we talked about today. Over time, it will become more and more clear, right? So let me give you one more example, which is kind of not new. It's the same thing we have talked about, but I just want to give you one more example, hoping to clear that things up a little bit more. So combining everything, right? So as you can imagine in real life, in the typical JavaScript code, you will have a mix of different scoping, right? So for example, you may have a variable in the global scope, global A. Okay, this is a global variable A, global A. And then I happen to have a function or the outer, right? A function here. And I define a B, outer local B, because this is a outer function, just to distinguish that, right? This is a local variable for the outer function B. So outer local B. And inside the outer function, I have a nested or inner function, or inner, very similar to the previous example we have seen. In here, I have a C. All right, so we have A, B, and C, right? So this is global. This is a function scope variable. This is another function scope variable. However, within here, right, we have access to C because it's a local variable. It's local, right? Relative to this line. Relative to this line, C is local. Relative to this line, B is a lexical scoped variable because it's defined in the outer function. So it is accessible. So I can console log C here, no issue, because this is local. I can console log B, no issue, lexical. And I can also console log A, no issue, because this is global. Right? I hope that clears things up a little bit more. So those are a few scoping that we have talked about in Udemy and also today. I think that is quite confusing for initially, so I do want to try giving you different examples to help you understand. Here I call inner, and outside I call outer. If I execute this code, it will print C, B, and A, all of them, right? So let's check. Yeah, so as expected, it prints C first, right? So here it can access C because it's local, right? The most straightforward. It can also access B because this is lexical, right? It's defined in the outer function. So it prints B. It also prints A, no issue, because this is global. It's accessible everywhere, right? However, if I try to access here, if I try to access C, it will throw an error because I cannot access C from the outer function, as C is a function scope variable only accessible within this scope. So this will not work, right? C is not defined because I'm trying to reference a function scope variable outside of the function, right? So you will notice that the reverse is true though, right? I mean, in the inner, I can reference B here, but from the outer, I cannot reference C because it's inside, right? So that means in here, I can access everything because it's the like uh, the deepest into the chain, right? In here, I can only reference B. Why? Because this is local, right? To here, B is local. You see what I mean? Like at this line, B is local, right? So it works. And A is still global, right? So here I can only access A and B because those are things that is outside of this line. And similarly, in here, I can only access A, that's all. Right? So as you can see, there is a pattern, right? As I go in more inside, deeper into the chain here, it can access everything from inside out, right? I can access C, B, and A from here, from inside here. If I go one level up, I can only access B and A because those are the only ones that are outside of me. And if I go to the outside, I can only access the global one. So you can think about this as like a room. Try to draw a picture. I hope you like it. So think of it as like a room. So you have a global room, global, right? A global room. Inside the global room, you have an outer room. Inside the outer room, you have an inner room. If you are inside the inner room, you can access everything on your way out, right? If you are in the outer room, you can only go outside, only one direction. So if you are in the inner room, you can access anything in inner room, and then on your way out, you reach the outer room, you can access the outer room, and then you're on your way out to the global room, you can grab anything from the global room. So you can access anything. So it will try to always go outside from inside out, right? From inside out. So and that's why if you are in the outer room, you can only access things that are inside the outer room plus the global room. But you cannot get in the room because you cannot go back inside. You can only go outside. Okay. So that may I hope that will help a little bit to try to understand those kind of scoping. Even if you do not remember all the types of scoping, if you have this picture in mind and you remember you're always going outside, depending on where you are, you know which kind of variable you have access to, right? I hope that helps. All right. So any questions before we move on? So this is a little more complicated, but don't worry because you can always go back to review again and again until you are super clear. Right? I try to cover everything the best I can. But if you do not fully understand everything, don't be discouraged. Try to keep reviewing those concepts. The most important thing is you know there's scoping in JavaScript. There's global scope, function or local scope, block scope, lexical. And there's a chain of scoping, which is like the picture with the rooms, and you can only go outside. So keep that in mind. Um, any question? I think I saw someone try to ask a question. Okay.
No question.
Okay. Is it, does it make sense? Everything okay here? Is everything okay here?
It's okay for me.
Okay, great. Perfect. So let's move on to the last topic. I want to go slowly this time. This is a very advanced topic. Even for some experienced JavaScript developers, they may not fully understand it. I can guarantee you, not everyone understands. Most people would have partial understanding. So I will try to go through that anyways. If you find it confusing, please do not feel discouraged. It's normal. Try to understand as far as you can. You can remember, you can always go back and review the material to clarify the concept. So what I want to talk about is something called closures. Okay, closure. So closures is a very important concept in JavaScript. So by definition, it means a closure is a combination of a function bundled together with some references to its surrounding state. I'm sure I lost you, right? So basically a function and a set of references to the things that it has access to. So a function with a bunch of valid references. That is called a closure. It's like something enclosed inside a unit. So it's easier to start with examples. If I, all right, so if I have, if I make a function called, so in Udemy, we talk about higher order function, right? Those are functions that can take functions as argument or return functions as return value, right? So this is related. And that's the reason why I want to talk about closures, because we talk about scope, we talk about higher order functions. If you combine the two, it is closures. So I have a function called function factory. If you look at something called design pattern, I think it's called design patterns. Design patterns. One of the patterns is called a factory pattern. So design patterns are basically best practices, patterns that that you're encouraged to use. There's actually many books that talk about design patterns, and one of the popular patterns is called factory pattern. Basically, it is a pattern where you have a piece of code that acts as a factory that generates something for you to use, right? So this is a factory pattern. So I have a factory function here, and in this function, I would return a function because it's a factory, right? So it return a function, and this function would do something, but it would print something, okay? Print something, but I have to define this variable x somewhere. So let's say I define this x in here. Right. So I have, so this is very similar to what we saw before, right? Outer function, inner function. This doesn't have a name, but doesn't matter. This is also still a function. So this inner function totally has access to x because this is lexical scoping, right? Accessing a variable from within an inner function, lexical scoping. So this will work, and it will print x. And since this is the main difference between of this one from the previous example is the fact that I actually return the function, right? Because in the previous example, I have a function here, I just called it, right? So this is a little different because I now have a higher order function, func factory, that would return a function. It generates a function. And that function will print x. So that means I can call func factory, and this will return a function. So let me store that function somewhere, my func, right? So I call the func factory to generate a function for me, and I store that into my func variable. So my func would have a reference to the function generated by the func factory. So that means if I run this code as is, it will do nothing. And I will prove that to you, right? It does nothing. Why? Because we have only generated the function. So we call func factory, it return a function, and that's it, right? It doesn't execute anything. It just return a function. I still have to call the function, right? If I call the function, I will see I will see the output. It will print x, right? It prints x, right? Because here I generate the function, I store that into my func variable. So this is a function. This is a reference to a function, and that's why I can use the bracket here to call it. All right. So this is a higher order function that returns a function. I generate that. I call it. So the significance of this example is that there is a closure. There is a closure. So the closure is this my func here. Because this is a function. Remember, closure means a function bundled with a bunch of references that it has access to. So in this case, the function is my func. And the reference that it has access to is x. And the reason why it has access to x is because this is a lexical scoping pattern. I try to access x from within an inner function. That's what it has access to. So the closure of my func here is the combination of the function returned by this factory plus the reference to x. This is the closure. So why is it important? It's important because if you notice that at the time I execute my func, the func factory has already finished execution. It's done, right? Here I call func factory. It's done. And it returns a reference to the generated function. When I call it here, it's kind of weird that it can print x because the x is defined by the func factory. And the func factory is already done executing, right? So it's very confusing, right? It's very confusing because I define x inside the func factory and I execute func factory here. It's done executing. And here, when I've run the generated function, it somehow has access to a variable defined in the func factory that has already finished execution. This looks really weird, right, initially. And the reason why it works in JavaScript is because of the notion of closure. So it's when you run func factory, it generates a myfunc function for you together with the references to the surrounding that this function has access to. So this function has access to this x here because it's a lexical scoping variable, right? When I return this function, it returns the function plus the references to x because x is the surrounding environment. So this is called a closure. And this is, in my opinion, the hardest thing to understand in JavaScript, to be honest. So if you do not fully understand, don't worry, but keep that in mind. the most important thing to remember is that closure is a function with a bundle, right? A bundle that has a function and the associated set of references that the function has access to. So that is called closure. So it is like locking the variable, right? It's kind of locked and closed. That's why it's called closure, I guess. It's locked inside this thing, so that even though this is done finished execution, you still have access to the locked, like a snapshot of the variable, the value. It is stored somewhere and is locked. Trust me, as you go through more example and you use that more and more, you will understand better and better. But for now, another example. So let's say I have another fun factory. Right? It returns a function as usual. And as usual, the inner function will just print something. But this time, it prints the argument. So fun factory takes an argument, arg, and it returns a function because it's a higher order function that returns another function. And that's why this is a factory pattern. And it support one argument. And then in here, on this line 3 here, I do have access to arg, right? Because this is an inner function, lexical scoping, it has access to the outside. So this is similar to the previous example, but the main difference is that I am not defining arg or the variable in here. I'm not defining that in here. Instead, I'm consuming the argument from within the inner function. But this will form a closure. That means this fun factory will return a function as a bundle with the references to arg. Is locked, is stored, is a snapshot, is stored inside this closure, is locked. So if I'm to do it, if I'm to run this fun factory, right? Let's say I pass x to it. So what happens would be x would be passed as the argument to fun factory, which can be accessed from within the inner function. This forms a closure. So this value of x is locked in this closure. So this would be a closure. So if I name it x, okay. So max would be a variable. Max would be a function that sorry, max is a closure, which is a function, but it will have access to the locked state of x. If I do something similar, if I now have a make y, for example, that would take y as the argument. So it will lock y. So now I actually have two functions, right? The two functions are generated by the same fun factory, but by passing in different arguments. And each of them will be locked independently. That means if I run make x here, it prints x because make x is a closure that has x locked in it. But if I do make y, it prints y. So I'm hoping this example would make it a little more obvious what closures really means, right? It's basically locking states of values in using this kind of pattern, right? So you can also think about closures as a way to associate data with functions that operate on the data. it is kind of similar to the notion of object-oriented programming that we talked about last time, I think, where you have a group of functions with associated data that the functions operate on, right? You may have a class, an object that has a bunch of methods. Functions within objects are methods, right? We talked about that last week. And very often, the data within that object or class would have some sort of relationship with the operations or the methods, right? So this is similar, but the main difference is that there is no class or object involved in here, just functions. But it operates in a way that is quite similar to the object-oriented approach, where you have classes, object that has methods and data, right? Similar concept. Basically, you're bundling methods with data. That's it. That's the main gist of it, right? So that is closure. So far so good. Everything is clear. Trust me, for me, it took me a long time to understand what closures really means. And I have only covered a few examples today. But when you later on, when you do more programming, especially when you do things like React.js, you write front end using React components, you will come across closures a lot. Well, not a lot, but from time to time. And if you do not have a good understanding on closures, you may have to fix some weird bugs. Because when you do, I don't want to confuse you too much, but keep that in mind, right? Let me close with one more interesting example. So just trying to relate this a little bit more to the real life to make it more practical. Let's say you are writing some web page, right? And you want to create a button that would change the size of the font on the page. Okay, so I have this Google search page, a bunch of text. Let's say I want to make a button somewhere. When you click it, it will set the font size to a different font size. So how can we do that? Of course, so let's say you want to make it like 12 point, another button for 24, and the third button for 46 point, for example. So of course you can make 3 buttons. You can make 3 functions, right? But then you will notice that, as you can imagine, right, you'll be repeating a lot of code because they are basically the 3 functions would perform the same stuff, basically. The only difference is the actual font size being different. So when you think about it, you will start to think about using a factory pattern, right? A factory that would generate functions so that if you pass a variable to indicate the desired font size, it will make a function that will set the font size to that size so that you do not need to create one copy of the function for each font size that you want to associate with some buttons. So how do we do that? So we make a function called make sizer. It would accept one argument, size, which can be 12, 24, 46, or anything, right? And this is a factory, right? So it's a higher order function that returns the function. So it return function, and this function will interact with DOM. So this is something we will talk about in a few weeks' time. Interact with DOM. DOM is document object model. So that it has to interact with DOM in order to do things on the page. So in here, we'll just, as a very simple example, we will set the document body. So document has a body. Document is this thing. This is the DOM. It has a body, right? So, and then we set the style, and we change the font size to some size. That some size has to correspond to the input size. So we use a template literal, and we reference the size argument, right? And we have to specify, yeah, I think it's pixel, not point. It's actually pixels. So in CSS, when you specify font size, you do pixels. So yeah, so this is a factory pattern. This make sizer would return a function that would change the size of the body to this size according to the argument. So that means if I call make sizer 12, it will return a function that will change the document body font size to 12 pixels. So let's call that a size 12. Okay, and we make two more, 24 and 46, right? So let's make a 24 by passing 24. So you start to appreciate the beauty of factories, right? Because it becomes very, very reusable and flexible. You don't need to repeat this code 3 times. You just need to call the factory to generate something for you. It's very powerful. So let's execute this code. Nothing happens because I haven't called any function. But if I now remember, we have 3 functions that we have generated, right? So if I call size 12, notice the change of the font size. I forgot to remind you to notice the change, but that's okay. So now let me call size 46, okay? And before I hit enter, pay attention to the size of this font, okay? It becomes gigantic, right? Because it's 46 now. So let's change it back to 24. There we go, right? So this is one example. This is one example of why closures are useful. Because I have 3 generated functions that are closures, and they have the associated state locked inside the closure. This has locked 12, this has locked 24, and this has locked 46. Those are stored or locked inside the closure. So function with associated data as a bundle that are locked, that is closure. So this is one example of why closures are useful, is important. And again, this is more like academic theoretical discussion. If you don't fully understand closures, as long as you understand this pattern, you know that you can function that returns functions that generate function for you so that you can call it, right? Then you're good. The most important thing is you know how to apply it, right? But I'm hoping you can also understand from a technical or academic point of view so that you have a very clear understanding of why this works and how. This becomes more and more important as you write React code, because in React code, very often you may have a loop that returns a list of things. Imagine you have a table, for example, right? You have a table, and each row have a button that you can click, and the button for each row has to operate on that row itself. So this would be a use case to use the closure, because you want that button to associate with that row itself, and you want that to be locked. Why? Because there is a loop, right? And once the loop is done executing, it generates the page or the table, and then you click the button. And when you click the button, you want to make sure the handler of that button would be associated with that role. So this is closure. But we will talk about that later when if we get a chance to talk about React. But this is just the same concept. So yeah, I think that's a lot. That's a lot for one day. And I'm not going to confuse you further. I do want to know if there are any questions or any comments or anything you want me to clarify before we close. I hope it helps. It's a little more complicated this time, but it takes some time, but it's not too bad.
Yeah, I think I can ask the students to watch again the video and try to type the code and to understand all the codes that I think there are 8 snippets that you type today. So
Yeah.
I think if good for them to, if you
Yes.
can type again and make sure that you understand the concept, what is the behind. So you can try by yourself.
Yeah, I think it's a great idea. Like you can review the recording, you can follow along, try to type, try to play with the example, the snippet that we have gone through today. Try to experiment that. Don't be afraid to change it or to play with it, right? That would enhance your understanding for sure. Yes. Yeah. Anything else? Any comments? Any questions?
Good. Yeah. And feel free to send message to Mr. Lee in the messenger group if you have any question, any concern. Okay, feel free
Right.
to send message.
Yeah. Yeah. Feel free to send messages. Or if you have any questions, you can ask that in the messenger. You can ask me in the next class anytime. Don't be shy to ask questions. This is